I'm Anil Kumar. Here is a test on radical operations for you. There are 9 questions. I'd like you to pause the video, copy them. First 4 are shown here. Then these are the next 4. Once you copy, try to solve them and then look into my solutions. And here is the last one, where we are going to also understand what is rationalization. Now let's begin and solve them or simplify them one by one. So we'll start with the very first one, which is square root of 75 divided by square root of 3. So in radical operations, you could also write them as square root of 75 divided by 3. So you could simplify first, which is square root of 25, right? Dividing 75 by 3, and square root of 25 is 5. So that is the result. When you are multiplying, you multiply the outside part first, 10 times 3 as 30, and the adjacent part, 2 times 2 gives us 4 within the square root. The square root of 4 is 2, so it could be written as 30 times 2, which gives you 60 as the final result. Now here we'll apply the distributive property. You need to multiply 3 square root 5 with each term inside the bracket. So you get 3 times 3 square root 5 times 2 square root 10. Take away 3 square root 5 times 2 square root 5. 3 times 2 is 6, right? So that could be written as 6 times square root, 5 times 10 as 50. Here we can write 3 times 2 as 6. Square root 5 times square root 5. You can directly write 5, or if you wish, you could write 25. Now, 50 can be written as 25 times 2. Split into factors with perfect squares. That's the whole idea. So it is 25 times 2. That dot in between indicates multiplication. And square root of 25 is number 5. So that gives you 25 could be written as 5 square root of 25. So 6 times 5, and we get square root 2 here, minus 30. This could be written as 6 times 5 as 30, square root 2 minus 30. If you want, you can also factor 30 and rewrite the given expression as 30 within brackets square root 2 minus 1. Any of them is correct. Now let's do the last one here. Now in this case, 8 could be written as 4 times 2. So we can write this as 6 square root 4 times 2. 4 is a perfect square. Similarly, 18 could be written as 9 times 2, where 9 is a perfect square. Now, square root of 4 is 2, so we could write this as 6 times 2. We are left with square root 2 inside, plus 2 times 3 square root of 2. 6 times 2 is 12, square root 2, plus 6 square root 2. Now 12 and 6, they are like terms, they can be combined. And we could write this as equal to 12 plus 6 as 18 square root 2. So that is how we could actually simplify this given expression. So let's continue and do part E now. We have 54, 24 and 96 within square roots. We have to write 54 as product of 2 factors. One of them should be a perfect square. Then it helps, right? So it could be what? 6 times 9 is 54, right? So we could write this as 6 square root 6 times 9 24 can be written as 3, it is 3 square root 24. 24 could be written as 6 times 4. 4 is a perfect square. And 96 can be written as 6 times. If I divide 96 by 6, I get 6 times 6. 16, I'm sorry. 6 times 16 is 96. Now, 9, 4, and 16 are perfect squares. So we could write them as 6 times square root of 9 is 3. Within square root we get 6 minus square root of 4 is 2. So 3 times 2 within square root we are left with 6, and 8 times 4 square root 6. Now all these are like terms since square root 6 is common, right? So we could add 6 times 3, 18, take away 3 times 2, 6, and take away 8 times 4, 32, with square root of 6. Now we can combine that. So we have to take away 38 from 18, that leaves with minus 20 square root 6. So that becomes the answer for the given question. Now we have square root of 28 plus square root of 63. 28 could be written as 7 times 4, and 63 could be written as 7 times 9. 4 is a perfect square. We could write this as 2 square root 7 plus 3 for square root 9 square root 7. And now they can be combined and written as 5 square root 7. So I hope the operations are clear to you, right? G and H. We'll again apply distributive property, but you could also use a formula. So let me rewrite the formulas for you, which you can apply. One is that A plus B times A minus B is equal to A square minus B square, correct? As you can see, it is square root 3 plus square root 7 times square root 3 minus square root 7. We could write this as square of square root 3 minus square of square root 7, which gives us 3 minus 7, which is indeed equal to minus 4. Now in the second one, it is a perfect square, right? So you could again apply a formula, which is A minus B whole square is equal to A square minus 2AB plus B square. So A is square root 2 for us. So we get square root 2 whole square minus 2 times square root 2 times square root 6 plus square root 6 square, right? Now square could be written in either of these ways. Square root 2 whole square will leave us with 2. And here we get minus 2 square root of 2 times 6, which is 12. And we get plus 6. 6 plus 2 is 8. Minus 2 times 12 could be written as 4 times 3, which is equal to 8 minus square root of 4 is 2. Taking it out, we get 4 square root 3. So that becomes the end result, right? Now let's take the last example, which is to simplify 2 minus square root of x plus 4 times 2 plus square root of x plus 4 in the numerator, and in denominator we are going to multiply x square root 12 by square root 3. Now in the numerator again we can apply the formula a minus b times a plus b equals to a square minus b square. That is difference of squares. So we could write this expression as a for us is 2, right? So we get 2 square minus square root of x plus 4 in the numerator, and in the denominator we get product of these two, which is x square root of 36. Now let's open this bracket. So we get 4 minus square root square, they're inverse operations. We get x plus 4 here, divided by x times square root of 36 is 6. So we could write this as 6, right? Now if you open this bracket, what do you get? You get 4 minus x minus 4, and the denominator is 6x. Now this is equal to 4 minus 4 is 0. So we get minus x over 6x. X and x cancel, so we get minus 1 over 6 as our answer. So I hope these steps are absolutely clear, and it's kind of a review which helps you to move forward with such radical operations. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.